Everything that you have done until this point is a linear equation. So what makes an equation? An equal sign. It's an equation because it's an equal sign. We can use these linear equations to represent real-life scenarios involving two variables. And then if you've been doing the exercises, you've seen that you can graph those lines on a Cartesian plane. Why are you able to do that? Because the x and y axis on a Cartesian plane represent x and y. Currently, up till this point, the line equation represents solutions to the scenario that lie on the line we've drawn. So this thing here, this statement, some people aren't going to click with that right now. That's the student over there asked me a question about it, and when it clicked, I'm like, all of these scenarios, all of these dots on the line actually represent something. If you can get that through your head, this topic should be pretty cruisy. If not, it's going to be hard for you. So let me show you a similar to a real life scenario where I can represent the solutions on a line. So we've got this Bryden guy. He's got a grocery. He buys pineapples for $2 each, watermelons for $3 each, and he's got $30 to spend on anything. If I represent X as the number of pineapples Bryden buys, can someone tell me what algebra would represent the cost of buying pineapples? If I'm going to buy X pineapples and they cost $2 each, what's a form of algebra that's going to tell me how much I'll spend on pineapples? 2x. Because each pineapple costs $2. I don't know how many I'm buying. I'm buying X of them. So the number of pineapples is going to represent the number of pineapples. So cost of pineapples is going to be algebraically 2x. If we're going to flow on from that, what would the cost of buying watermelons be in this situation? Yeah?
3y.
3y. Cost of watermelons is going to be 3y. Do I have a linear equation I could write to represent Bryden buying these fruits? Yeah?
2x plus 3y equals 30.
2x plus 3y is the cost of all the fruits. How much does he have to spend? $30. So if you have been doing the exercises, you've been doing questions like this, okay? This can therefore be drawn on a Cartesian plane. So you can check my working out for me if you want. I don't tend to get things wrong. This line is the equation 2x plus 3y equals 30. Can I give you a few minutes, please, to get that example down and also sketch this graph, because we're going to refer back to this multiple times. Don't write this black stuff. That's to help me teach it to you. But I want you to draw this scenario in your book so we can refer back to it after a few minutes, please. I have asked IT to replace the lamp on the projector because it's kind of dim. But room's still better than D17 because there aren't children barking or laughing or singing. and you won't have to wear earplugs for your test, yeah?
Right, so why did we move from the 17th to 18th? It wasn't
You weren't here on Friday.
Yeah. Why did
That's
we...
all you need to know.
Oh.
The children were barking.
Uh,
I'm not kidding about it.
how bad was it?
Really bad.
It was like
Well,
super
1 to
loud.
10.
You couldn't hear me.
Yeah, I could hear.
And your test was annoying as well, okay?
Yeah.
From my perspective, during tests, I kind of want the distraction, because if you can handle the test with that distraction and the exam is perfect conditions, you'll cruise. But if that's going to be lessons, I can't teach against people barking, okay? All right, let's try to make this click. Shh. Right now, you've just got equations, but this is a picture of that equation. And what this is a picture of the scenario, because every whole number grid crossing on this line is a solution to the scenario. So here, what's this point? What's the coordinates of that point there? X is what?
0.
X is 0 here. X is 0 and Y is 10. What does Y represent? Y is the number of watermelons bought. So would it be possible for Bryden to buy 10 watermelons times by 3 is 30? See how that dot there represents a solution to the scenario of him paying exactly $30 for something? Is this on a whole number grid line? That dot there. Is it in line with 8 and is in line with another whole number on the x-axis? This dot here?
Yep.
Yeah? That dot is 3, 8. What does that represent? Buying 3 pineapples. 3 pineapples cost $2 each, $6 plus 8 watermelons. 8 times by 3, what's that? 8 times by 3, 24. 24 plus 6, does that equal 30?
Yep.
So that's another combination of things he could buy. Okay? So what I'm trying to illustrate here is every dot along this situation that's a whole number is a possible solution to that scenario. Spending exactly $30. This one is 9 and 4. This one is 12 and 2. What's this last one here? This one is 15 and 0. 15, the x-axis represents the number of pineapples. How much do pineapples cost? $2. So would it be possible in Bryden's scenario to buy 15 $2 things for $30? Is that the solution? That's what this equation is telling you. Okay? But what we're adding this time that's why you need coloured pencils. So I'm going to style this to be see-through. This is additional notes. Is in real life, what tends to happen? You tend to have the ability to spend up to and including 30. You don't have to spend exactly 30. You've got enough money to spend less than 30 all the way up to 30. Can you spend more than 30 if you've only got $30? No. So to achieve this, how do we achieve this? We use these signs here. It's probably been since year 10 since you've seen these. This one stands for greater than. This one's less than. What does the extra line indicate? Tell me. Greater than or equal to. Or less than or equal to. So equations written with inequalities now represents regions, not just lines. Okay? So the addition to this is inequalities represent regions on a Cartesian plane. Unlike line equations, where we represent points on the line only, if we have inequalities like this, these signs indicate the region up and or right of the line that they represent. If they're pointing to the left, that's less than or equal to. These signs indicate the region down and or left of the line they represent. So get these 2 points, and then I want you to help me colour in and tell me what regions we're talking about in the graph above. So get these 2 points here. Greater than or equal to means that you're colouring in up and or right of the line. And these signs here, less than or equal to, means that you're colouring in left or down and left of the line that they represent. Couple of minutes for those two, and then I need to scroll back up and ask you a couple of questions about that graph. You'll work on the exercises for, let's say, 40 minutes. Question?
Yeah, are you doing the lunchtime tutorials here, or
No, still in D17.
Okay.
If you're just chilling in D17, I don't mind children barking. All right, let's have a look back at this graph. So, this blue line is the equation 2x plus 3y equals 30. You tell me. This has an inequality on it right now. It's 2x plus 3y is less than or equal to 30. Where does this go? Does it go below the line or above it? What do the notes say? If it's less than or equal to, is to the left or down. So this region, that region is everything below the line. What about this one here? That's 2x plus 3y is greater than or equal to 30. Where's that region going to sit? Up and to the right of the line. And I ask you, oh, that's too bright. What could I do? Yellow, maybe? 2x plus 3y is greater than or equal to 30 is up to the right of the line. Which of those regions makes most sense for Bryden? He's got $30 to spend. So can he spend more than 30 or can he spend less than 30?
Less than 30.
So this, what the exercise, after you've done 2A1, your exercise is all going to be about regions where you're representing real life, okay? He could spend up to and including $30. What does this line represent? This line represents spending exactly $30. If I've got any points in this yellow area, I'm spending more than $30, okay? So your work for now, can you go until 12 o'clock, please? Can you do exercise 2A.1, all of feasible regions, please? All of feasible regions, please. For your timeline work, I'll be back with you in 40 minutes.